to prove. Right, to prove. So ln phi I from our expression, we have got mu I minus mu I here, right? Very good expression here, which is 1 by RT mu I minus mu I IgM T x. What you do get if you do that is very straightforward. You have to just divide by RT with the term. So first term will be minus ln Z B mix Z minus B mix plus. So we have to divide by RT. That means BIT by RT. If you remember, it's capital B. Capital B, right? So capital BI by Z minus B mix minus A mix by RT. A mix by P by RT square. What is that? AP by RT square. Something we have defined long back. A, capital A mix. Capital A mix. Capital BI. Okay. By B mix. What I have done? How to get capital BI? Divide by RT. Numerator denominator. So it will be capital BI, capital B mix. Okay. But so far you are not getting anything what is given. Only one term is matching. We don't know how to get this one. Then this term is over. Next, plus third term 2 summation j equals to 1 to c aij nj by nb mix, it should be RT minus a mix bi RT b mix square ln z by ZB mix this term is okay. This term is also okay. You will see that something like that I am getting here. So problematic term is looks so straightforward, but this term is so problematic. I am saying term number 2. This term is okay, last term is okay, you cannot do mass simplification, but simplification is required for, I think something is missing here, right? 1 by z plus b mix. How to proceed? See, the final expression is like this. That means this is not the final expression, you can further simplify. How to simplify? Let's see how we can simplify. Second term, which is Bi by Z minus B mix minus A mix Bi by B mix into Z plus B mix. If you combine it, it will be Z square minus B mix square. Am I correct? Numerator term will be Bi B mix, capital Bi, capital B mix. What will the another terms? Quick. It's very simple. I am just doing partial fraction, just combining. I am doing partial fraction, just combining. Quick. I am just combining. What will be that? Rahul, how many terms? 4 terms will be there, right? Yeah, tell me the terms, quick. Remember that we have taken Bi and B mix outside. Man, this is so much time it is taking. Yes, the divider.
Z plus.
Z plus. Bi B mix is taken outside. Sir, you look at the board. Yeah, so if I take this, how the Z plus B mix will come? Because taken outside.
Yes, Z
to B mix. B mix Z plus B mix square minus A mix Z plus A mix B mix. Why Z plus are not coming? Only Z is not coming. That's what I am saying. Where is only Z? That's what I am saying. You know, this simple thing I have to shout. Then what do you expect? Correct? Yes? Okay. So I am denoting B mix as B because I am sick and tired with writing A mix. I can say A. So my second term is Bi by B Bz plus B square minus Az plus AB by Z squared minus B squared. What the simplification? These terms can be simplified. That's what I am saying. This term can be shown as, I'll tell you what it can be simplified. Bi by B into Z minus 1. Can you imagine? This term is nothing but this. How to prove it? And I will show you why Sandler and all the other guys could not do it. Only I could do it. I will show you that. Simple. This thing is nothing but Z minus 1. How to prove it? Okay, we are doing SRK, Swave-Bradley-Poisson equation. I will take only this much board space. For Swave-Bradley-Poisson equation, what is the polynomial, Z cube polynomial? Do you have the table with you? Long back I have given. The cubic polynomial in terms of Z I have given. One table I have given the coefficients. Z cube plus alpha Z square plus beta Z plus gamma equal to 0. Where are alpha, beta, gamma? For SRK.
SRK is alpha is minus 1.
Minus 1, so Z cube minus Z square.
Beta is A minus B minus B.
A minus B minus B square.
And gamma is minus A.
Gamma is minus A. AB equals to 0. AB, not A, minus AB. So from here, can you see how we can get this one? This is the catch. If you don't use that, you cannot get this one. So what we have? We have minus BZ from here, BZ plus AZ minus AB minus BZ plus AZ minus AB equals to how much it is coming? Z square minus Z cube minus plus B squared Z. Am I correct? Yes or no? From the equation. That means here you can see BZ is there, AZ is there, sign is changing, okay, plus AB. So we need only one extra term, which is term, what term is required? B squared term is required. Okay, so BZ minus AZ plus AB plus B square will be what? Equals to? It will be equals to, remember, change the sign. Yeah, so it will be equals to? It will be equals to? B square minus Z square plus Z cube minus B square Z equals to, can you factorize this? If you see that, if you take Z square minus B square, it is also minus 1. But if you take outside, Z square minus B square, it will be Z square minus B square into Z minus 1. Am I correct? Z square minus B square is there, denominator. That will be getting cancelled, so you will be getting Z minus 1 here. Okay? So, your final expression will be, now we can actually see how the final expression is coming as Z minus 1. Here. Okay? Understood? So, this part they could not do. So, that was the failure there. So, if there is a catch. Okay? We will see the same thing in Payne-Robinson equation of state. Okay? So, we will do fast Payne-Robinson. Now we know the thing. Payne-Robinson is much tougher. Payne-Robinson equation is, no book again discuss the Payne-Robinson equation of state. I have done it. Again, one more night I put for that. Okay? And let's go for the Payne-Robinson equation of state. Are you liking this exercise? Math exercise? There's no thermodynamics. I'm not doing thermodynamics here. I'm just teaching the math. Basically calculus and partial fraction. So we'll go for now PRUS. What I will do PRUS, I'll directly asking for dou P dou Ni. Why I'm going to write all those things. So first I will write, so now we'll do PRUS, Payne-Robinson equation of state, which is P equals to RT by V minus V, AT by V square plus 2VV minus V square. You know how to do it? Because small v is replaced by capital V by N, and then any summation j equals to 1 to C and all other things. So if you can do that, what will happen for dou P dou Ni T P N J, J not equals to I? One, two, three, four term will be coming. Now we have done SRT, you should do very fast. That's good that in Friday I am getting one class together because we go back home for 10. Now you can do very fast because we just finished the SRT. Dou P dou Ni for the Payne-Robinson equation of state. Okay, anybody is ready? So first two terms I write for you. RT by V minus NV mix plus nRT VI divided by V minus NV mix whole square minus two summation j equals to 1 to C Aij Nj by, let's see who can help me, by, not Rahul, you got it, by, but you can tell me not the partial fraction, just tell me the what will come. I won't go so fast because yeah, that's okay, but if I go by fast, then many people cannot follow. What's the term? Anybody else? We have done just now for the SRT. Same procedure. Same procedure is very straightforward from here. Just follow the procedure, you get the answer. What you got there, what we are getting here. Second bench, any answer? Madam? First express in terms of capital V. Take the derivative with respect to Ni. We have done so much. No need to any simplification. It will come automatically. First term is very straightforward. These two terms came from here. From here you get two more terms. First term is very straightforward. You can even see from here what is the first term. The first term you can see from there. First term is written in the board actually. Right? First term you can get from the board. Denominator term. Can you help me? Who can get the first term? Not Rahul. There was no way, right? That's what I am saying. It is written, I said it is written in the board. You see, as an engineer, you should have some kind of intuition. Sometimes students show me the result. Sir, I have written the computer program with the result. Do you think I go and check the computer program? I don't have time. By seeing the result, I can see the result is correct or wrong. That is called intuition, engineering approach. From here, intuitively you can actually tell me what's the answer. What is that? Not B, capital B, plus capital B is B square, 2 B N B mix minus N B mix square. So it is exactly coming from here. That's called intuition. Right? That's called intuition. B square plus 2B N B mix. The B is replaced by N B mix. You know that. Small b is replaced by capital B by N. N is going top. So capital B is remaining here. Okay? And this is coming from the ddx of u by b. So first term, that's what I have done. And that's what I expect the answer from you guys. Last term. Last term. Last term. Last term will be what? Last term will be what? Last term definitely denominator term is the whole square, which is b square plus 2b nb mix minus nb mix whole square, numerator term. It's very straightforward. dx of u by v, v du dx minus u dv dx. That u dv dx term is coming from here. The v dv dx and all those things. So what is actually coming? v du dx minus u dv dx. U is what? 80. U dv dx is coming. Yes. Pardon? 2 should not be there. That's why you don't care for 2. 1, 2 and all those you don't care. 2 should be there. No, 2 is coming here, no? Huh? Or go 2, then there is a common term, no? Yes. So 2n square, a mix, bi will be there. Bracket 1 minus capital B is there, no? Capital B minus NB mix. Did you get capital B? See, so much of hard work I have to do to get the answer. When I did myself, I didn't put that much hard work. It was very easy for me. Everything is okay so far. Okay. Next, mu I minus mu I gm, TPH bar. I want the answer in terms of Ln form. Mu I minus mu I gm This is one of the questions for the end semester. Find the Fugacity coefficient, derive the Fugacity coefficient for the van der Waals, not the Payne-Robinson equation of state. Mu I minus mu I IgM TPX bar. What did you get? Nothing but v prime tending to infinity to v RT by v prime minus RT by v prime minus NV mix minus nRT VI by v prime minus NV mix whole square plus summation j equals to 1 to c aij nj by b prime square 2b prime n b mix minus nb mix whole square minus 2n square a mix bi b prime minus nb mix by b prime square 2b prime nb mix minus nb mix whole square b prime. Got it? Yes or no? Yes. Okay, the challenging term will be, I am saying I1 and this is I2. This term is okay, we can do it. We have done it. This term we have done it. This term also you can do it. B prime minus 2b prime b, partial fraction. This term and this term. Okay? I will not do derivation here because this will be the subject of end semester. So I will give you the final form of Fi. The final form what I derived, it took me again one more night. So 2 nights I spent. So let's see whether you can do it. We have so many nights left. Okay. So I'll give you the final expression for the Ping-Lorentzian equation of state. Ln phi I equals to minus ln z minus b mix plus bi by b mix z minus 1. See, we are also getting z minus 1. That means that there may be some trick. Let me see the polynomial. The polynomial is very complicated here. It is not that easy. It is not like your similar, but we are getting the same kind of result. Very interesting part. Plus a mix by 2 root 2 RT by b mix bi minus b mix minus 2 j equals to 1 to c aij xj by a mix into ln z plus b mix into 1 plus root 2 divided by z plus capital B mix 1 minus root 2. This expression I copied from Sandler. But unfortunately Sandler doesn't have procedure. I have the procedure. The expression has been copied from Sandler's book. So copyright, this expression is copyright of Sandler, not me. Procedure is copyright by me. You cannot find any books. If you find, please show it to me. I'll be very happy. Next time I can refer. But if you find a book, that's it. Your problem is solved. Right? Let's see. So this is the possible question for end semester multi-component fugacity coefficient for end semester exam. Okay, so this ends the entire derivations for the multi-component fugacity coefficient. As you are doing for the first time here, right? You have not done in undergrad. The first time you have done, you have got the expression for the fugacity coefficient for the fugacity for the ith component. So before ending the fugacity part, I would like to note what will happen for the Gibbs-Duhem equation for the multi-component fugacity. If you remember, if you try to recall the Gibbs-Duhem equation. If you try to recall the Gibbs-Duhem equation for fugacity, what's the Gibbs-Duhem equation you have found? With the partial molar property, right? The partial molar property. If Gj bar, the partial molar Gibbs energy, what will be the Gibbs-Duhem equation for Gj bar? Any idea? If Gj bar is the partial molar property, partial molar Gibbs energy, what will be the Gibbs-Duhem equation for Gj bar? What will be the Gibbs-Duhem equation for Gj bar? What will be the Gibbs-Duhem equation for Gj bar? What is the Gibbs-Duhem BJ bar and just see that what level I can go to. Everything is there in the notes. You are so even lazy that you can't even read out from notes. What's the Gibbs equation for BJ bar? I'm just seeing the level of my equations. Yes, summation. J equals to 1 to C. Xj. For Gj bar, what do you do that? By equals to 0. I am not asking to derive it. I am asking to go through from the notes, and that too it took some time to see the notes. This is known. What will happen for the fugacity? For Gibbs equation for fugacity, I am asking that show that summation j equals to 1 to c xj dou ln phi j by dou xi equals to 0 output. Now you know multi-component fugacity very well. We have done from the equation of state, 3 different equation of states, we have got it. How to get it? See the definition first. Fi by pxi, which is exponential of mu I minus mu I igm px bar by RT. This dj bar, I can write this as j equals to 1 to c xj dou mu j by dou x equals to 0. Gj bar is nothing but mu. Partial experience is nothing but chemical potential of the particular compound. So from here, can we write j equals to 1 to c xj dou xi mu I minus mu I igm px bar equals to 0. Can I write? Yes or no? Because, sorry, it should be mu j. Xj dou xj mu j equals to 0. Summation that is coming. Same for igm. If you subtract that, it will be becoming 0. Okay? Then your job is to prove it. Again, the possible question of exam. I won't give that. I am giving the hints. Then your turn to prove it. Now I will be starting the non-reactive system, last part, multi-phase, multi-component. And I guess you have got Professor Ravi's handout. Did you circle to the class? Yes. That's the thing. I have chosen a wrong person. I thought, no, that's what. Don't tell any stories. You have not done it. I have given long back. I told you please do that before the class. I have chosen a wrong person. Every point I am seeing that I have chosen a wrong person. I don't know. There may be a better person I could have sent to Sriram, but I thought that you are in the class, you are my PhD student, but you don't get. So Professor Ravi has written a nice article, and unfortunately we don't have that because I sent to Sir, and Sir is so much busy and he doesn't even care for the entire class, and Sir is not giving. So Sriram, actually I can give it to you today if you can forward to the entire class some mechanism. Okay, so I'll forward because I don't trust you, because you may say again mistake, right? No, 2 days. That time also you say that you will do it, right? You told me that you will do it. I don't know. You will say forget, and I don't accuse it. It's my mistake because I've chosen. You don't have to be feeling sorry. I feel sorry because I chose it, right? So Professor Ravi has written a nice article on that. So that is the multi-phase, multi-component. I hope by Monday this article will be coming to you. Okay. This is I have got the PDF file. I thought we'll submit the PDF file to the class. I don't know whether he can do it. So Professor Ravi has written the article. And the article is basically on degree of freedom. So this reference I am actually giving is a very recent article, still in press, just got accepted. Hot cake. This article is a hot cake, just got accepted. Industrial Chemistry Research. Okay. So that article is very important. I want to refer that, and let's look at what is known by degree of freedom. We all know that the degree of freedom is C. What is that? C minus P plus 2, right? How to prove it? Multi-phase, multi-component. Number of components, number of phase plus 2. How to prove degrees of freedom C minus P plus 2? Any idea? Anybody can have a proof for me? How to prove it? No idea how to prove it. So we'll see, and that we can actually see much fundamentals. I will discuss some fundamentals, and you can refer to this article by Professor Ravi in Industrial Engineering Research, which is in press right now. So, for example, we have equation x plus y equals to 2. 2x plus y equals to 3. Algebraic system. If I want to know degree of freedom of the system, df, number of algebraic equations minus number of unknowns, or you can say minus number of algebraic equations number of plus number of unknowns. What it says that if number of unknowns equals number of independent algebraic, I should write independent algebraic equations, then you get unique solution because degree of freedom is 0. Just like a vector space in mathematics. Any vector space problem can be done in terms of degree of freedom. Number of unknowns 2, number of independent algebraic equations 2, degree of freedom is 0. That says that your solution is unique, 1 and 1. The solution is 1 and 1. Now, if I have x plus y equals to 2, 2x plus 2y equals to 4. I again have two algebraic equations, but one is dependent. So I have number of unknowns 2, number of independent algebraic equations 1, degree of freedom is 1. That means degree of freedom non-zero means that there are multiple solutions. And the number of degree of freedom says that if you can fix one variable, then only your solution is unique. If you fix one variable, then only your solution is unique. Okay? If you fix one variable, then your solution is unique. Okay? Funda clear? So degree of freedom 0 means you are getting unique solution. Degree of freedom non-zero means you have multiple solutions, but number of degree of freedom will tell you that how many variables you can fix independently such that to get the fixed solution. And in this case 1. That means if you fix a 1, if y equals to 1, you get x equals to 1. If you fix y equals to 2, x equals to 0. Solution of x is fixed. If you fix x equal to 3, y equal to 3, x equals to minus 1. That's the meaning of degree of freedom calculations. So with that, we will start the entire thermodynamics, the degree of freedom concept. Okay? So let's look at the degree of freedom concept from this knowledge and proceed further. So we'll be doing multi-phase, multi-component. So let's look at what I mean by algebraic equations or equations in thermodynamics. We have for pure substance, you have Q hat SB, H equals to H hat SE, A equals to A hat DB, right? G equals to G hat E. You have got that? Here only one equation is independent, and this can be obtained from Legendre transformation, right? Or if you say this one, this can be an independent equation, not all. So in thermodynamics, equations means I believe these equations. Based on combined first and second law of thermodynamics, what we have learned. For multi-component substances, this is the pure substance. For the multi-component substance, we have U equals to, you have SV, then SV, X1 to Xc minus 1. Yes, X1 to Xc minus 1. H equals to H hat Sp X1 to Xc minus 1. A equals to A hat Pb X1 to Xc minus 1. G equals to G hat Pp X1 to Xc minus 1. If you look at this may be independent equation or this may be like this. When I talked about x plus y equals to 2 and 2x plus 2y equals to 4, either of these two is independent, not both. Because this is obtained from this. Similarly, this all equations are obtained from this. You can take either of these as independent. Same thing is here. Okay? So, we have got independent equation, maybe this one. Okay? We'll say further from here what are the algebraic equations. I'm not talking about algebraic. These are not algebraic equations. Remember, these are differentials. Right? Algebraic equations come further when you talk about the evaluations. Because unless you have algebraic equations, you cannot talk about degree of freedom. Okay? So that's the way you can manage the evaluation. So now, right time to have independent variables. Degree of freedom says that number of independent algebraic equations minus number of independent variables. How many independent variables here? For this thing, c minus 1 plus 2, c plus 1. So you have c plus 1 independent variables. What are the, if I take this one, variables are p, x1 to xc minus 1. These are my independent variables in thermodynamics. I am talking about now multi-phase equilibrium. I am talking about multi-phase equilibrium. If I talk about multi-phase equilibrium, then you can find algebraic equations. If we talk about multi-phase equilibrium, then you can write two phases. I will take only binary phase. First phase, second phase, components 1 to c minus 1, 1 to c component, and in terms of nc is that xc minus 1. So my multi-phase equilibrium algebraic equations will be, what are algebraic equations for equilibrium? Two phases, we have done it earlier. Equilibrium, two phase, P1 equals to P2, P1 equals to P2, and for optimization, we have found mu1 equals to mu2, but for here, for every component, it will be mu I1 equals to mu I2, correct? Yes? I equals to 1 to C components. So for pure substance, we have only 3 independent equations. Right? For pure substance, if I say I have a pure substance, two phase, 3 independent equations, P1 equal to P2, P1 equal to P2, P1 equal to P2. So for pure substance, let me talk about pure substance first. Pure substance. Equations are P1 equals to P2, P1 equals to P2, mu1 equals to mu2. Pure substance two phase. 3 algebraic equations. How many unknowns are there? How many unknowns are there? 6 unknowns. Unknown means independent variables. For first phase, my independent variables are pure phase, pure component. For first phase, my independent variables are P1. Second phase independent variables are P2. What is my degree of freedom? Pure component 2 phase. Degree of freedom is 1. How it is coming? 4 minus 3. If you look at your formula, C minus P plus 2. C means 1. P is 2 plus 2. So 2 and 2 will get cancelled. So it is coming out. Not clear? So this concept was not clear, not done in your undergraduate, right? How to get degree of freedom. So for pure substance, you can see that you have simple water vapor, nothing else, water and water vapor. Degree of freedom is 1. Degree of freedom is 4 unknowns, 3 algebraic equations. Your degree of freedom is 1. 4 minus 3 is 1. Right? Let's look at the C component, multi-component, multi-phase. We talk about now. With this example, we can easily go to the multi-component, multi-phase. I think I will stop here. What I will do that, you can go back home and try to see whether you can derive multi-component, multi-phase, so that we can see next class how we can proceed. Thanks for attention.